All right, this is exam 3 for Physics 102. Which of these is constant for appliances in your home? Well, in your home, everything operates at a constant voltage, but the current can change, the power can change, and the resistance can change. So we're looking at B, one only. On a circuit breaker, you have these devices, and then you add this device, the blender, and it turns off, which is the maximum allowed current. Well, the current is power over voltage. So we take each of the powers and divide by the voltage, which is 120 volts. So like 1200 over 120 would be 10 amps. This would be 2 amps, and this would be 3 amps. So I have 10 plus 2 plus 3 equal to 15 amps running on this circuit at a given time, and everything's going okay. But then I have this 4 amp device, and that gives me 19 amps, and somewhere between 15 and 19 it turns off. So I just look for a number between those two values, and so that'll be 18. Consider this circuit a discharging RC circuit. For these values for R and C, it's fully charged by this battery. What is the charge on the capacitor after 5 seconds? Well, for a discharging RC circuit, the voltage is initially big and then it gets small, so it looks like this. And the function looks like this, V equals V naught times e to the minus t over RC. And so V, or I'm sorry, I don't want to know the voltage, I want to know the charge, but that's okay because the charge function looks exactly the same. And the charge function, I just get rid of these V's and I put in my Q, and this is the big Q, which is going to be C times V times e to the minus t over RC. All right, so I have 10 microfarads, that's my capacitance. The voltage is 10 volts. And that would give me microcoulombs, but that's what I'm looking for anyway, times e to the minus 5, and then R times C, that's 2 times 10. Notice I have mega and micro, and those cancel out, so I have 5 over 20. And when I do that, I get 10 times like 0.77, so it comes out to be, or excuse me, not 10, 100 times 0.77, so it comes out to be 80 microcoulombs. So A is the right answer for number 3. And now number 4. Which of these statements about a household circuit is true? The household circuit is a combination of series and parallel circuits. Not true. Sorry. All devices in a household circuit operate at the same power. Also not true. They operate at the same voltage. As you add more devices, the voltage across each device decreases. That's not true. That would be true for a series circuit, which it is not. And then a circuit breaker turns off if the incoming exceeds the outgoing current. That's not true. It turns off if it exceeds a set value, say 15 amps or 20 amps or whatever. So it's like none of those are true. Electron moves through a region of electric and magnetic fields. There's the electric field and it's directed straight down, and the magnetic field is directed to the left. At what velocity of the electron into the paper will the electric force exactly cancel the magnetic force? So you have a magnetic force in one direction and an electric force in the other direction. The electric force is going to be up and in this direction, and the magnetic force will be down and in that direction. And I just want to know what velocity gives me those two forces being equal. So the electric force is equal to Q times E, and the magnetic force is equal to QV times B, and the angle is 90 degrees. So I'm looking for V. Look, my Q's cancel, that's convenient. And so V is equal to E divided by B. E is 1,000 volts per meter, or newtons per coulomb. Remember the double units are, they can have either, divided by 2 Tesla, so it's going to be 500 meters per second. So number 5 is C. Which of these is the voltage versus time for a discharging capacitor? Well, gosh, I think I did that one earlier, so it is going to be A. That's the voltage versus time for a discharging. If it was a charging capacitor, it would look like this, but it's not. It's discharging. Actually, it looks more like that. 2 coulomb charge is traveling at 6 meters per second in a magnetic field, orthogonal to the velocity, and has a magnitude of 3 Tesla. What is the magnitude of the force? Well, this one is fairly straightforward. F equals QVB. That's 2 coulombs times the velocity, which is 6 meters per second, times the field, which is 3 Tesla. And by the way, these are all not very realistic quantities that you would have small charges, small magnetic fields, but big velocities. I just did this to make the math easier. So that's 36 newtons. C is the right answer. Which of these statements about the magnetic force on a charged particle traveling through a magnetic field is true? The magnetic force is parallel to the magnetic field. That is never true. It is always orthogonal. The magnetic force is always opposite the electric force. That could be true, but not necessarily. The magnetic force can change the energy of a particle. That is never true. The magnetic force is a centripetal force. It only changes the direction of the speed, not the magnitude of the speed. So E is the right answer for number 8. Current of 30 amps in a circular loop with a radius of 0.1 meters, and the loop has 10,000 turns of wire. What is the magnetic field generated by that loop? Well, you want to remember the equation to find the magnetic field due to a loop of wire, and that is this N mu naught I over 2R. That's on your equation sheet, but be careful because we also had a very similar equation that had a 2 pi r in it for the magnetic field due to a long straight wire. So you just have to know those different equations. The N should sort of clue you in. 10,000 times 4 pi times 10 to the minus 7. I is 30 amps. That 10,000 is the number of turns, divided by 2 times 0.1 meters. And that gives you the magnetic field that's generated by this loop in the middle there. For number 9 is 2 Tesla. How are natural magnets created? A is the right answer here. Some of these others, those things might be true, although D isn't really true. But A is actually how those things are created. The Earth's magnetic field plays a role in the aurora. Which of these best explains why a permanent magnet is magnetized? It's because the magnetic domains are aligned. Positive charge is traveling towards a wire. What direction will the charge travel when you turn on this current? Well, you use your right-hand rule in a couple different ways. First, on the wire, it tells you that there's a magnetic field into the page and out of the page. So this charge is traveling into a magnetic field out of the page. So my velocity is to the right. So my force then is down, letting my fingers fold towards the magnetic field, which are out of the page. So 13 then is D. Figure shows 2 wires, each of which has a current I at point P. Which of the arrows shows the direction of the net magnetic field? You want to consider the magnetic field of each. So let's consider the one on the right first. It has a magnetic field up at this point that's in this direction, right? Because we have this magnetic field that sort of goes around, and so at this point it's tangent to that circle. And then in a similar way, due to this circle, or this wire rather, which is out of the page, it has a magnetic field in this direction. So it goes like that. So B is the right answer for number 14. A negative charge enters the magnetic field as shown. What direction will it feel a force? All right, use your right-hand rule again. V is up, B is out of the page, and that tells you that you get a force to the right, but then you realize, oh, this is a negative particle, so it's not to the right, it's going to be A to the left. Positive particle travels into the page through the north and south poles of the magnet. So my velocity vector is into the page, and my magnetic field vector is from north to south pole, so it looks like that. In order for the particle to go through undeflected, you have an electric field that's also present. What must be the direction of that electric field? Well, first let's figure out what is the direction of the magnetic force, and then we'll figure out the direction of the magnetic field. So V is into the page, B is to the right. So the magnetic force, FB, has to be down. That means I have to have an electric field which gives us an electric force that is up. And so the electric force and the electric field for a positive particle are in the same direction, so 16 is A. Organize these in order of longest to shortest wavelength. All right, microwave have the longest, followed by visible, followed by X-ray, followed by gamma ray. So microwave, visible, X-ray, gamma ray. D is 17. Which of the following statements is true? Newton believed light was a wave because of reflection. He believed it was a particle because of reflection. Einstein believed light was a particle because of the photoelectric effect. That's true. Huygens believed light was a wave because of refraction. That's true. Young believed light was a particle because of the double slit experiment. Okay, Young believed light was a wave because of the double slit experiment, which we didn't talk about the double slit experience, but that has to do with interference of light. we'll have a whole chapter. So 2 and 3, A is 18. Two mirrors set an angle of 130 degrees to one another. A ray of light is incident at 70 degrees. I will fix that for 19. What is the angle of reflection with respect to the perpendicular line for the second mirror? Well, if this is 70, then this is 70. And if that's 70, then this is 20. And so I get 20 and 130, that makes 150. So this angle must be 30. And if that angle is 30, then this angle is 60. And so this angle is also 60. So A is the right answer for number 19. Light travels through three media, as shown here. Rank them from highest to lowest index of refraction. All right, so you want to list them N1 and 2, N2 and 3, and then N1 and 3, and then we'll figure it out. But we'll look, consider our wavefront model of light. Pardon me. Our wavefront model. Here, it looks like this one speeds up. That means that it speeds up in medium 2, so N1 is bigger than N2. It's traveling from a high index to a low index, so it moves away from the normal. And then here, looks like it slows down, so N3 is bigger than N2. And then we also need to consider the relationship of N1 and N3. Think about here, and then here. It is slowing down and traveling around, so that means that N3 is bigger than N1. So N3 is the biggest, so I get rid of all of these. And then the next one, N1 is bigger than N2, so C is the right answer, number 20. Listen, MCAT really likes to have these orderies, or any standardized exam like to have these ranking problems. So, be able to go through these types of problems and think about the different answers that you can get rid of, that you can eliminate. Material has an index of refraction of 1.5, then the speed of light is what? Well, N is equal to C over V. So V is equal to C over N. It's 3 times 10 to the 8th. That value is on your equation sheet, meters per second, divided by 1.5, so that's going to be 2 times 10 to the 8th, so 21 is E. Light travels from glass to air. The index of refraction for glass is 1.5. What must be the incident angle for total internal reflection to occur? All right, so it's traveling from glass to air. I already know that it is going to occur because it's going from a high index to a low index. It's just like a fiber optic cable, right? It's glass or plastic, so it goes from a high index to low index. That means that it's going to bend away from the normal, and I want to know it such that this angle is 90 degrees. I want to know this angle, theta 1, so I say 1.5 sine theta 1 equals 1 sine of 90. And so theta 1 equals inverse sine of 1 over 1.5. And let's see. Get 42 degrees. So B is number 22. The following figure shows a fiber optic cable. In order for total internal reflection to occur, which of these statements about the indices of refraction must occur? Well, you can have fiber optics that's just glass within air on the outside, or you can just have a cladding, because sometimes you might want to protect the integrity of that core, but it always has to be that N1 has a bigger index of refraction than N2. N1 must be bigger than N2 for that total internal reflection to occur. Mirror produces an upright image. The object is 8 centimeters high, and to the left of the mirror, the image is 4 centimeters high. So look, my magnification then is 4 over 8, or a half. And it says it's upright. That also means that it's virtual. So that should be enough to tell you that we're dealing with a convex mirror, that I have an object that is to the left of the mirror, and the image is smaller and to the right of the mirror. The center of curvature of the mirror is 8 centimeters. So that means that my focal length is negative 8 over 2, which is negative 4 centimeters. It's 4 because it's 8 divided by 2, half the center of curvature. It's negative because it's a convex mirror. So you first have to identify it as a convex mirror, and then realize that the focal length is negative. So I also know that m is negative q over p, and that m is equal to 1/2, 1 over 2. So I can say that p is equal to negative 2q. And when I do that, I can say, well, 1 over negative 4, that's F, equals 1 over P plus 1 over Q. But now I'm going to do this substitution and say this is 1 over negative 2Q. All I did is I took this and I put it in where I had P before. And now I'm going to solve for Q. Negative 1 over 4 equals 1 over 2Q. So Q then is equal to negative 2. Is that what I'm looking for? Yeah, I'm looking for Q, so it's 2 centimeters to the right of the mirror. It's negative, so that means that it's to the right of the mirror. Negative 2 centimeters also means it's virtual, right, when it comes out negative. So that all jives with what I think. So number 24 is C. Security mirror, oh gosh, another convex mirror. So I need to remember that the focal length is negative. So my F is equal to negative 20 centimeters. P is equal to 40, and I just want to know what is the magnification. So I first want to find Q. 1 over negative 20 equals 1 over 40 plus 1 over Q. This is going to be negative 1 over 20 minus 1 over 40 equals 1 over Q. So Q equals minus 40 over 3. I'm just going to leave it like that for just a second because you'll see why. Though if you did it as a decimal, that's okay. I want to know the magnification. It's negative Q over P. It's going to be negative 40 over 3 divided by P, which is 40. So these cancel and make them both positive, and it makes it 1/3, positive 1/3, which for a convex mirror, we know that's the case. In fact, you could have looked at this and said, security mirror, convex mirror, let's get rid of this one, and this one, and then B has to be the answer, because that's the type of images that convex mirrors produce. What does a concave mirror produce? Well, a concave mirror, when it's inside the focal point, I produce an image that is upright, virtual, and bigger. So C is the right answer for 26. Oh, and well, this is exactly the same. So this is a concave. I might take out one of those. We'll see. And now let's look. Consider these rays. Which of these rays are drawn incorrectly? So here, notice that I'm at the focal point. And so you know that at the focal point for a concave mirror, all of my rays should be parallel. So at least 2 of these rays are wrong because they're all none of them are parallel to one another. So I can get rid of this one and this one. It's got to be either D or E. So let's look at these rays. Ray 1 goes parallel to the axis and then through the center of curvature. That ain't right. Ray 2 goes through the center of curvature. Remember how we did this, where it originates at the center and then it goes up, and then it should go back upon itself, but it goes through the focal point. That's not right. And then this one goes to the center of the mirror, and it should follow the law of reflection. That looks like it does, actually. Those 2 angles are equal. So D is the right answer. What's your favorite class this semester? Well, it ain't that. Boot camp PE. It could be that. Oh, but wait, no, because I got this option down here, so it's definitely not inorganic chemistry, although Dr. Doe is awesome. But the answer is D.